Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Dear students, let me continue with this function of logarithm, logarithmic function. The domain we are saying r plus. Let me explain using an example. Why are we saying this r plus? Alright, say you know this conversion already. So let me give an example. You have 2, correct? 2 to the power 1 is how much? That is 2 itself. Now if you want to write this in terms of log, let us say, so I want to write this 1 is equal to log, what is the base for the exponential here? Base is 2, so the base for log is also 2 and this 2 is here. So log 2 to the base 2 is 1, correct? Now what about 2 to the power 0? 2 to the power 0 is 1. So hence when I write this in terms of log, how do I write? Log to the base 2 and this will come here. So log 1 to the base 2 is 0, correct? So from this what you understand? See, two formulas you understand here. The first formula is that log a to the base a, log a to the base a is always 1. You may have anything here, provided this is positive. Again I will come back to that. Then what is log 1 to any base? Okay, so log 1 to any base, you can write a or b, it doesn't matter, that will be always 0. So log 1 is 0 always, and if you have same numbers here, that will be always 1. So these are the two things that you understand from this example. Let me continue. Now what about 2 to the power minus 1? Yes, so 2 to the power minus 1 is half here. So that means log to the base 2 half is equal to minus 1, is equal to minus 1. Understand? Log x to the base b, x is coming from r plus, so x cannot be negative at all. That means this number cannot be negative at all. That means this number cannot be negative at all. You take positive power, you take 0, you take negative power, go on like this. You take minus 2, minus 3, minus 4 and so on. If you take minus 2, this will be 1 by 2 square, 1 by 4. If you take minus 3 here, 1 by 8. It goes on like that. This quantity will never be negative. It won't be negative at all. It will be always positive. This will be always positive for any power, So that's the beauty of this exponential, that is never negative, never negative. All right, so that means this number can never be negative. This cannot be negative at all. See, this can be negative. You may get a negative output. You may get a negative output. This y can be negative, but you can never have this x negative. That will be always positive. I hope you understood this concept. So therefore the domain of log is always positive real numbers. Log cannot take a negative. So log is always positive. It has a very positive outlook on life. That is never negative in life, okay, never depressed. So log is always positive, so think positive. Well, now that's enough for this positivity. Now let me tell you something. There are two types of bases, all right. So importantly, and they have a specific name for that. Others do not have a specific name. There are infinite bases basically, correct? In place of b, you can take any number, any real number which is greater than 1, right? Well, now if the base is E. Alright, see what is this E? E is actually limit of 1 plus 1 by n to the power n. Okay, so limit of this quantity is nothing but E. So that you will learn when you learn what is limit. Okay, so see, basically the value of E is, it is 2.718, it continues like that. Okay, irrational number. Well, and that is one explanation. The second explanation, you have summation n is equal to 1 to infinity, and you have 1 plus 1 by n. Okay, so when it goes to infinity, you will have E. So that means 1 by 1 factorial, and then 1 by 2 factorial, 1 by this is n factorial, I'm sorry. Okay, so it goes on like that. Now that's the value of E. That's the value of E. Don't worry too much about this quantity E. You will learn later. But for time being, remember, if the base of the logarithm is this value E, all right, then such a logarithm is called natural logarithm. Okay, this is called natural logarithm. In some textbook they simply write ln. See, if you see ln, you should understand that this is natural logarithm. Natural logarithm, that means the base is E. In maths, we simply write log x is equal to y. What is the base then? We don't mention any base there. See, if you don't mention any base, then it naturally means that it is E. If the base is E, you don't have to mention it. Okay, so that's the word you should remember, natural. So naturally what comes is E. All right, so that's what we consider as the natural logarithm. Well, there is a second important base, and that is 10. So if the base is 10, then log to the base 10 x, this is called common. Okay, so this is called common logarithm. So that must be mentioned. So besides these two things, you have infinite bases. You can have 2, you can have 3, you can have whatever. Okay, any real number you can have there. All right, so that is and that must be greater than 1, right? Must be greater than 1. Well, so these are the two things that you must bear in mind. The first thing, what is the meaning of natural logarithm? That means if the base is E, then this is called natural logarithm. If the base is 10, then that is called common logarithm. So these are the two types of the bases, okay, the important ones. And then there are so many other bases which are not which do not have a specific name given to it, because these are the most frequently used bases. Well, now let us understand a few properties of this logarithm. The first one being you have a formula to convert. Now that you have learned two bases, correct? You have natural logarithm and you have a common logarithm. Now how do I switch between them? So you have a formula for that, and that is nothing but, see, if you have log A to the base B, now I can change this base B. So how do I change the base? The base can be changed using this formula. See, log A, what shall I write here? I'll just write m Okay, you can write any base there, doesn't matter, and this will be again m. See what has happened here, the base for the log has changed. When you wrote the log here, you had the base b, but when you came here, you have changed the base for the log as m, and here also you must write the same base, and this quantity will go in the numerator. Okay, this quantity comes in the denominator. Well, so this is the formula that we have to change the base. For example, if you have e here, okay, so you have natural logarithm. All right, so you have the natural logarithm. Now you do not know the value of this, you have only a common logarithm table given to you. So how do I find? Otherwise you can find sometimes the values directly if you convert to common logarithm. So I'll take the base 10. Okay, I take the base 10, and this is also 10. Now this quantity can be easily found. What is log e? That is a constant. All right, that's a constant definite number. So you can divide by this quantity to convert from e to 10. You can change the base from exponential, I mean e, okay, natural logarithm, to the common logarithm. So this is the way we can convert, we can switch between the bases. You can have any other base, it need not be 10 itself, it can be 2, it can be 3, it can be any base basically. All right, how do you verify? From where did you get this formula? So let us verify this. Okay, see what do? I take these three quantities and convert them to exponential. That way I can understand better, because you are very good at exponentials, correct? The indices basically we have learnt in this preliminaries. Well, so we will convert to indices and understand this concept of log and this particular property. Well, now I'll take this as alpha, right, and next I'll take the next quantity log a to the base m as beta, fine, and then the denominator here, that is log b to the base m as gamma. So alpha, beta and gamma. Now how do I convert this to exponential? That is b to the power alpha. Now what will be independent? A will be independent here. We can find a if you do not know a using this exponential, correct? So that's the reason we are converting, and in this case we are converting because to understand the property. Let's continue. See what is a here? A will be m raised to beta. So the base is b here, the base is m here, correct? And similarly the base is m here, so gamma, and this will be independent, correct? Yes. So so much is clear to you. Now look at this m, correct, and you have a similar case here, that is also m, and you have got a here. Now what I can do is I can take these three quantities, manipulate them and get the formula that is required to me. Well, you just take this as equation number 1, and this let me take it as 2, and this let me take it as 3. So you have got 1, 2 and 3. Now look at this, you have b here, is it not? And you have b here as well. So what I'll do is I'll take the first equation and the third equation. So from first equation and the third equation, what do I get? So from the first and third, see what I'm going to replace is this b. So in place of b, what I'll write now? So b is m raised to gamma, and this alpha, and that is equal to a. I hope you have understood. I have taken this equation, replaced b, that's it. Now look at this. This is nothing but the indices formula will tell you that this is alpha into gamma. These must be multiplied, that's it, correct? And this is a. Now this a from equation 2 is equal to m raised to beta. So this is m raised to beta, and that is from second equation. That is from second equation. Well, now the bases are equal, that means the powers are also equal, the indices are equal. Now finally, what is alpha? What is alpha from this? I hope you understood the sequence here. Okay, so now this is beta divided by gamma, that's it. Now what is alpha? Alpha is nothing but log a to the base b, that is equal to beta divided by gamma. What is beta? Beta is log a to the base m divided by gamma, and that is log b to the base m. So alpha is equal to beta by gamma. So using exponentials, using indices, we have made this so simple, and that's how it looks in the exponential form. But when it comes to log, this looks like this. So remember the log property here. See, if you want to change the base, you can always use this form. So you must change the bases. Okay, change the base from b to m, and this quantity will be in the numerator and this quantity will come in the denominator. That's the first property that we have learned, and that is always compared with the always converted to the exponential form and understood better. Second property also is understood in the same way. And what is that second property? Second property is if you have addition of two quantities in log. Okay, so that means you have log x plus log y, both must be of the same base, then only you can add them, otherwise you cannot. Now that would be equal to log xy. So understand, if you have addition here of log, then you will have multiplication inside log. Okay, so let us verify this again using the conversion, again using the technique of converting to exponential. So we'll convert these three things to exponential and understand in the similar fashion. Okay, so our property will be clear to us. So if you understand the reason behind this, it's better to remember, it's easier to remember the property, and that's the reason I'm explaining the verification part here. Otherwise you can just learn this by heart and use the formula in the problems, but you won't understand the reason behind it. Once you understand the reason, once you know what and how of this, then you will remember this forever. Okay, so that's the way you must learn all the formulas. Now how do I verify? As I said already, I will take them, okay, I will take them as alpha, beta, gamma as usual. Okay, so I'll take it as alpha, and the second thing I will take it as beta, and the third thing I will take it as gamma. Okay, well, now in the exponential form, how does this look like? This looks like the base will be same for log and exponential. This comes as the power and x will be independent. Yes, and here b to the power beta will be equal to y. Now y is independent, here beta was independent, correct? And here xy will be independent, and that is equal to b to the power gamma. So these are the three things that we have just got from the logarithms. Now let us just manipulate them. Let us just manipulate them and get this formula. So understand, you have b and you have b here as well. There also you have b, same base. Anyway, I'll just work with these two things. Okay, so what is xy? What is xy? See, one xy is b to the power gamma, correct? Another xy is multiply these two things. So in place of x I will write b to the power alpha, and in place of y I will write b to the power beta, correct? So now what do I understand is b to the power gamma. See, what did I start with? I started with xy. When I took xy, I understood that xy is nothing but b to the power gamma. So I wrote it here. Then again when I look at xy, see, I have the x value, so I replaced, and I have this y value as well, so I replaced it, correct? So basically starting with xy. Now what I have ended up with, b to the power gamma is equal to b to the power alpha, b to the power beta. You know the property of indices, if the bases are same and they're multiplied, the powers will be added, correct? So now powers will be added here because the bases are same, okay, and they are multiplied. Now this is b to the power gamma. So if the bases are equal, then powers, the indices also must be equal. So gamma is equal to alpha plus beta. If I write this in proper order, alpha plus beta is equal to gamma. What is alpha, by the way? Alpha is log x. So log x is alpha, and what is beta? Beta is nothing but log y. Beta is nothing but log y, and that is equal to gamma, they are saying, okay? So what is gamma? Gamma is log xy. So log xy, and all those three things are of the same base. See, if these two are of the same base, then only you can add them, and the resultant, the answer, the sum of it also will have the same base. Only the difference, these x and this y will be multiplied here. Why? Because of this reason. Because of this reason, if you have this multiplication of two quantities with the same base, then powers will be added. So if the powers are added, then these two are separately multiplied. So that's the whole logic behind this formula. So if you have addition, you will have multiplication. So please remember this reason and remember the formula. So please understand. If you understand this reason, you will definitely remember the formula, okay? So please go through this concepts of logarithm, why the domain is positive, please understand that, and then what is log a to the base a will be always 1, what is log 1 to any base will be always 0, and the next property, change of base, and then this property is of addition of two log quantities, okay? So how do you add two quantities with log? You just have to multiply these values, and bases must be equal. Well, so that's it for today's class. Thank you very much for watching, okay? So keep watching these videos, you will learn maths in a better way. So thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.